Okay, so good morning, good evening, and thanks for joining us on today's session. My name is Shani Shoam. I'm the CEO of North America for WekaIO. If you've joined us on prior webinars, we alluded to modern workloads, but didn't really characterize them and discuss some of the challenges in supporting them. Julia Palmer, VP of Research at Gartner, is probably the best person to do so. With over 19 years of experience in the storage and HPC market, she literally saw the industry changing in front of her eyes. She'll be joined by Liran Zwiebel. Liran started his storage journey at XIV, which got acquired by IBM, and is now the co-founder and CEO of WekaIO. A few housekeeping rules, actually just two of them. We want to keep this session interactive, so feel free to use the chat to ask any questions, and I'm going to try and interject them between Liran and Julia's slide. But we do want to hear from you. We do want to again make this session interactive. We are recording this session, and we'll send the recording in a few days. And so if you missed a certain part or anything like that, then do expect an email from us with a link to the recording. One last item before we get started. So most of this session is going to be about artificial intelligence and machine learning workloads. So just before I hand it over to Julia, we'd love to hear a little bit from the audience. What kind of AI and ML workloads you are running, if any? And again, Liran and Julia are going to use those inputs during their session. So I'm going to launch a quick poll question. Again, we want to make this session as personalized or customized as possible, and so we'd love to hear a little bit of some inputs from you. If any or multiple characteristics that are currently showing up on the screen would characterize the workloads that you're running. So with that, Julia, over to you.
Perfect. Thank you so much. Well, very well welcome to the world of modernization of the storage infrastructure. Thank you for the warm introduction. I work for Gartner for IT leaders. I used to be an IT leader myself. So I really feel your pain as far as modernizing storage infrastructure for the new workloads. And when we're speaking about new technologies, in the next slide, you'll see we're talking about, hey, this is a new technology that you must embrace. But if you'll not, what will happen to you? You will be left behind. When I started to learn about the world of AI/ML infrastructure, I thought I knew everything about storage. You cannot surprise me. We have everything until now. But as we started to learn this specific workload, we realized it introduces very unique challenges, something that you have never faced before. So IT infrastructure is in a state of continuous change. And it can be scary and exciting, but if I know anything about IT people, I know they're not easily scared, right? So we're here to get ahead of the game and learn more about both AI/ML workload and how do we rethink storage for this. So Gartner, on the next slide, you'll see we have a lot of CIOs we're talking to, a lot of CEOs we're talking to, and we actually asked about 3,000 of them, what do they think about artificial intelligence and machine learning? We were a little bit surprised that they said it's one of the most important workloads in the future and most advanced technology they're going to utilize to move forward for both internal and external business. And 2 out of 5 of them already have small deployments, and they're already toying with the idea of releasing it or maybe having it already in production. But what was most exciting and also a little scary is that 85% of them already looking to use it in the next 2 years. So are you ready for this? You better be ready for this because it's coming your way. Either you know it right now or not. So let's have a look on the next slide in what is AI/ML all about and why is it so unique and why do you need to learn about it and think about it a little differently. This is an overall pipeline for machine learning and AI. You can see here, there's a lot of moving parts, and it's okay if you feel overwhelmed right now, but just think about it. We have new data coming in the pipeline. This data goes into data lake. Sometimes it needs to be cleaned. It needs to be classified. A lot of things happen on data collection and integration phase. This is one phase. Then data gets into being prepared to actually being used into model training. Model training is happening in a very, very, very resource intensive stage of AI ML pipeline. And then we're going into inference. And at the end, data is going into production deployment, and the cycle keeps going and going. So I know, you know, the AI ML specialist, and that's okay. There is so much time to learn about it, but let's have a look at this from storage perspective. As you can see up front, is a very data intensive as far as application. On the back end, it's very latency sensitive. But to make it even more complex, it needs to be delivered at the edge, sometimes in the public cloud, and sometimes on-prem for any of those phases. So you understand now that it's kind of a complex issue, because you might be collecting data in a major data center, and at the edge locations, you might be doing model training in the public cloud or on-prem, but inferencing can be done at the edge. So it creates the very unique problem also to storing all of this data. Because remember how one of the Google executive once said, we don't have a better algorithm, we just have a lot of data. So here we're talking about huge scale of data we need to keep. So let's dive deep into something that's probably going to be more near and dear to your heart. On the next slide, we see how is the storage going to react to it. And you can see here, well, let's leave data ingest apart. Let's assume it's been happening and you already have your data on your side. The next thing, it needs to be prepared. You have a lot of extreme high throughput operations, a lot of sequential writes is happening on the data prep stage. And then when data moving into model training, it's probably where you hear a lot about storage problems here, because we need high throughput and low latency. Have a lot of systems that are designed for either or, but in this stage, we need both. And when data moves into inference stage, we need extreme low latency operations, right? Maybe smaller IO, maybe mixed workloads, but extreme low latency is what's important. And the last but not least important stage of the data workflow is actually active archiving. Remember, we talked about this large amount of data that need to be stored because you're only as good as how much data you have. That's pretty challenging as well. Here we might be talking about multi-petabyte scale of active archive, right? So it's a very, very unique requirements. You're probably looking at this and saying, oh my God, am I going to have to deploy 5 different storage systems? And you would be right. Sometimes if you don't partner with the right solution, you don't pick it right at the very beginning, you might end up with 5 cumbersome systems. And to make matters worse, they also will require some kind of a management data lifecycle on top of it to move data from little stages. So if you think about it as a separate systems, you're going to be in a world of hurt real quick. And that's what we learned from the early adopters of AI/ML infrastructure. So what is the bottom line? As you can see on the next slide, what are we saying here? The different stages of AI workloads might require different infrastructure because they have different characteristics and different requirements, and will force you to deploy technologies. So is there a problem there? Yes, absolutely there is a problem, but that is why you need to think about storage for AI ML infrastructure very, very differently. And that is why you will see now there's a new emerging vendors and startups coming to the market with those unique solutions to address those issues that I highlighted earlier. And so we have a couple of things to talk about here, right? Probably can spend more than an hour to dive in deep in all of the solutions and problems, but I wanna pretty much for you to think about just 6 aspects of it as you move forward, right? So AI infrastructure is different and unique in those 6 aspects from everything you had so far. the portability, interoperability, scalability, cost optimization, performance, and software nature. Liran, do you have anything to add here?
So definitely, these are also the things that we see that customers care about and make a difference. And I think one big aspect that we figured out recently, and we're actually changed how we view what we're doing and what customers need. You keep saying that storage has issues keeping up with these different requirements, and this is true. And that's actually the reason recently we've renamed what we're doing to a data platform. Because if you look at storage, you're either buying a SAN or a NAS or an object storage. And as you've said, each of these distinct solutions is not good enough. And then you have to go and buy another product or a battery of products to get the whole workflow work. And what we've done at Weka, we've actually created new kind of way to look at managing, accessing, distilling data so customers don't have to do that anymore. And I think this is the main shift that we have done. We don't look at it as being storage. We look at what we're doing at holding your data and making sure it's the perfect way to treat your data. Does it make sense?
Yeah. Yeah, I totally agree. I think storage operations is moving towards data operations, and storage guys need to assume ownership of data. And when you face in with something like this, something as complex and demanding as the AI ML workflow, you're going to embrace the new solutions, including data management and not just storage operations. So diving a little deeper on how do you select storage for AI ML infrastructure, you will see that there's 6 aspects of this, as we say. So on the next slide, we will see how does it reflect on uniqueness of the solutions you might have a look at. So first one is portability. So what is portability? Portability reflects the requirement of delivering storage anywhere. I tell people data center is no longer center of data. Data must be delivered, orchestrated, and consumed anywhere. And yet, most of the storage solutions on the market designed for single data center. So you need to forget about this. You should always ask about portability factor. And it might need to be deployed at the edge, or might need to be entirely in data center, or might need to be deployed anywhere. So obviously, this is the #1 requirement, portability of the solution. And this is one thing about solution itself, but now what about data? Data also need to be portable. So you need to embrace technologies that can move data from the edge to the cloud, or from the data center to the cloud, or maybe even vice versa. So one thing is a solution portability, and another thing very important about data portability itself. Because it could be the situation that you decided to do model training in the public cloud, but you will do inference at the edge. So data might need to be moving between different delivery options. So #2, scalability. Well, obviously, it's very important. And people always talking about large scale, especially for unstructured data. But they never thought about it, that architecture also needs to change, because large scale is very important, but also ability to scale down, because a lot of AI ML projects start very small. So you don't want to invest in petabyte solution if your initial stage requires a small footprint, or maybe you're just doing some proof of concept for some kind of tools and trying to figure out the appropriate hardware. So you want to be able to start small. So it's not just about large scale, but it's also about starting small and growing. And as you notice here, we didn't use the term as NAS, network attached storage here. You know why? Because it's a vertical platform. Vertical platforms cannot scale to the sizes that we need here for this particular workloads. Why they might be perfectly fine for anything else, but for AI ML, you need scale out file system. You need a distributed file system, because we're talking about multi-petabyte scale, sometimes dozens of petabytes. You need a distributed system, right? You need be able to support billions of files, you need to be thinking about it. How's metadata gonna scale? So that's why distributed horizontal design, cloud native design, some people say, is the way to go when we're talking about scalability. The third thing is performance. Yes, you guys saw it already. It's almost unthinkable that this workload requires everything: high throughput, large I/O, and the random reads, random writes, small I/O. Both throughput oriented and latency oriented workloads need to live in harmony together. It's very difficult to do. That's why we need new protocols, we need new flash media, and most importantly, we need new software that can leverage all of this. This is something that was a real big challenge. Another thing about performance, here in a training phase of AI ML, you have a very expensive components, GPUs, and they need this fast storage to be utilized fairly, because otherwise you're wasting money, your GPU sitting there waiting for the storage IO to come, and it's really not cost-effective solution to use outdated storage file system. And another thing to think about it on performance, a lot of systems can do very impressive performance numbers when you test them, but can they sustain it? This is something about sustainable and guaranteed performance, because AI ML workflow is not steady. It could be spikes. It could be different activities happening at the same time on the same storage system. So we need to pay attention to the guaranteed data and metadata performance. That's why we have to have metadata that can scale out with the capacity and not being bound to the one particular deployment. And interoperability, extremely important, right? We're not working here in a silo. AI ML needs to support a lot of new and modern ML libraries. It needs to be able to be deployed alongside and self-provisioned by developers or business owners. So you need to be compatible with tools they're using for provisioning. They need to learn all of the APIs and making sure they can handle it, and making sure they can handle it in a self-service mode as well. But another thing to think about it is it also needs to support modern platforms. Here we're not talking about VMware support. It's mostly, Kubernetes oriented applications that are being right now in development. So if you're not picking a storage system that fully embedded and managed and compatible and popular to be deployed is Kubernetes, you're probably going to feel that it's not a solution that can be supported on a long term. Right now, software defined is all of the craze, but to be honest with you, for AI ML workload, software defined is kind of a thing to do. As you can see, when we talked about portability, we're talking about being able to deploy anywhere. So software defined needs to be appliance independent, needs to support this latest hardware innovation. When let's say NVMe first came to the market, who do you think was the first vendors that started to write new code for NVMe and NVMe Fabrics protocols? It was the software-defined storage vendors. They're the first ones that embrace the new technology. So they're the good partners to work with when you talk about AI ML workflows, because they're moving much faster, hardware independent, leveraging latest hardware. And again, back to our hybrid cloud infrastructure. If you are working with software-defined vendor, they are completely neutral and they don't care where you deploy your software, the edge, in the public, and the cloud, and they designing it with that in mind, that it should be able to run anywhere you want. And of course, the last thing, that's not the least important thing, it's cost optimized. So you need to right size your storage investment. And a lot of times when I work with people, we're talking about storage for training space. When people say storage for AI ML, they probably think about storage for the most demanding, performance demanding phase. Maybe inference as well. But they're not talking about entire cycle of life cycle management of storage. And what happens then, that they're deploying all of their data on this single platform, which becomes pretty big and pretty expensive. And they become overwhelmed and they realize they cannot sustain it. So what does it mean? It means the platform that you're choosing need to address all of the phases of AI/ML, including active archive. So it needs to find a way to move the data once it's no longer relevant to the different types of media, different types of cost-effective solution, just as scalable, but maybe not as expensive for this active archive stage of the AI/ML process. And furthermore, for the deep archive phase. So it needs to be able to engage with this type of tiering on the long term and not being an afterthought. So that's where we're talking about total cost of ownership. People usually happy to spend money on tier 0, tier 1 for model training and model inferencing, but with deep archiving, it becomes as an afterthought and it becomes a very expensive solution if you don't think about it on a day one. So a lot of things to digest, but one thing that I want to share with you, how to avoid mistakes. This is something that you probably thinking, oh my God, this is so complex, what not to do. So this is something that I can share you with the people that I worked with, and they came back to me and they said, I wish I would have done differently. One of them, you need to use shared storage solutions. You cannot start with something that direct attached storage or something that does not scale. You need to have a consolidated data platforms, because if you're going to deploy them in a silo and start moving them around later on, it will be a nightmare for data management, and it needs to be automated. Otherwise, it's going to break. Obviously, you want to think about systems that leveraging latest flash technology, but also latest protocols like NVMe or fabrics. You don't want the fabric to become the bottleneck for your infrastructure, because you might have a fast storage, but if your fabric is a bottleneck, you're not gonna get best performance out of the storage system, right? IO bottlenecks are always moving, so this is something to keep your eye on. And that's something that people were saying, that if you deploy a solution just on the one side, bottleneck will move somewhere else. So chasing the bottlenecks is something you don't want to do. You wanted to start designing it, all of the pieces together. The most important thing, figuring out, can you deploy the storage that will keep GPUs utilized well. Consistent and linear growth in performance, this is something that definitely on people's top of the mind, because as you add capacity, you need to add performance. And right now, certain solutions, when you start adding, let's say, NVMe drives, you can saturate controller very well. So on the day one, your performance is great, and then you add in more storage, but your CPUs are actually not being able to support the storage media. So that is something that you definitely wanted to think from the day one. How are you going to grow performance at scale? And don't think about performance alone. I know it's probably counterintuitive, but when you're talking about AI ML, but you actually need to think about it. Hey, today I have 1 petabyte of data, but I'll be ingesting data constantly. And how will my solution look at 10 petabytes, 20 petabytes? Do I figure out where I'm going to store it, where I'm going to archive it, how it's going to look like, and how do I deliver the solution across all of the things like cost and portability and scale and interoperability requirements? Will it work for bare metal deployments? Will it work for Kubernetes and things like this? So those are a few things to think about it. I can never let you go, guys, without my favorite quotes of my favorite guy. And it is complicated. It is definitely a big challenge, but there's an opportunity. There's time for you to embrace this new workload and embrace the new technology, learn something exciting to move forward with, and become a hero. Imagine, 85% of your CIOs already thinking about it, implementing it within 2 years. So time is now. Back to you, Shani.
Thanks, Julia. I imagine Liran will have a lot of comments about the requirements, the data mobility, definitely about Kubernetes and software-defined storage. There's one question from the audience, which I think I know the answer, but I'll let you kind of take that. which talks about, you mentioned 6 requirements, but you didn't mention high network bandwidth. We actually did a survey. We saw that there's a lot of transition to 100 gig, 400 gig. So just the fact that you didn't mention that stood out to Mohsen. And, you know, I don't know if that was intentional or you just don't see that as part of storage requirements, but yeah, I would love your feedback on that.
Yeah, it's absolutely a requirement. I think we're talking about this in how to avoid mistakes, you know, reduce the bottlenecks, right? That can be bottleneck, can be a network. And it wasn't before because the storage was a bottleneck, but now with the modern storage, it's absolutely important to figure out your network strategy and the network bandwidth. Usually you will face it much later in a project. So we didn't have a lot of people complaining this on the day one, but as they grow, it's absolutely a requirement to have a look at your network for performance at scale.
Perfect. Appreciate that. And Mohsen, I hope you got the answer. Just before we transition to Liran, you know, Julia talked about a couple of requirements, you know, for supporting modern workloads, and would love to ask you, the audience, what's the biggest gaps that you see in terms of where you are today compared to some of the requirements that that Julia mentioned. So Julia talked about portability and kind of data mobility, about the ability to scale on-prem, in the cloud. Of course, performance was a key factor, interoperability and data silos, and last but not least, TCO. So would love to get your inputs on what are the biggest gaps. We're going to leave that poll question up for another minute or two. And with that, I'd like to transition to Liran.
Yeah, thanks, Shani, and thanks, Julia. So we've actually built a company, and we started doing it 7 years ago in 2014, that our company, Weka, addresses all these issues. So when we started Weka, we wanted to build the perfect storage for the requirements of 10 years from now, and we're actually getting close. And what we're seeing is that a lot of the bleeding edge customers already are having the problem that we assumed we'd see like in 2023, 24, 25 already today. And we're actually fortunate for AI and machine learning to make such a big entrance into what's important for the CIOs, what's important for the business. And now there's also new roles, what's important to the CDO. And this is not something we've foresaw, but we've recently even changed the name of what we're doing from storage to data platform, because we've realized, hey, what's really making the impact, what's important for our customers is Weka handling their data. Data is actually the fuel that lets the engine run. And we're now focusing on looking at the solution from the perspective of the data and making sure customers can better utilize their most important resource, because all customers buy the same engines. You go and you either buy the DGX from NVIDIA or the equivalent from one of their OEMs. So you all have the same engine, but each one of you have your different data, and Weka lets you utilize your data the best way. So I want to go through the important pillars that Julia mentioned and show how Weka is actually answering them, and why with Weka you can get a single solution to actually handle all of your data challenges in a way that allows you to beat your competitors. So let's start with portability. So as Julia said, the day of the single data centers, it's gone. So customers today, they have their own on-prem data center when they're trying to run most of their processing on, because it's the most cost efficient, but they want DR, cloud DR, another data center DR. They want to be able to spill over to the cloud, leverage the cloud for elasticity. And another thing that emerged with IoT and with new kind of applications is there is tremendous amount of happenings at the edge. And if you're stuck using legacy solutions, you end up having different products and different ways of treating your data and accessing your data on your data center, on your public cloud, on your edge, maybe on the actual IoT devices. And this actually introduces significant amount of added complexity, friction, and cost. And the other thing customers are looking for is increasing their data mobility and, more important, data access, because they want to be able to actually access the same data from whatever they're running. So Shani, if you can progress to the next slide. At Weka, we actually allow you to run a single solution, leveraging NVMe, leveraging fast networking. By the way, going back to that question, we're seeing the majority of our customers using 100 gig networking today, but there is an obvious shift to 200 gig networking, and we have some customers already on 400 gig networking. So the question from that, the audience question was definitely spot on. An important aspect of how customers actually need to access the data is have different protocols all accessing the same data. So multi-protocol is an important aspect of portability. At Weka, we have our own shared POSIX that allows you to actually get higher performance than what you traditionally would have gotten with direct attached or even a local file system over SAN, which used to be unheard of a few years ago. But we're also enabling SMB. If you have some Windows, mostly SMB is required for live humans or some devices that are Windows-based and they need to ingest NFS, are again other kind of Unix-based devices that just need access. Really important one is S3. So your IoT devices need to be able to ingest data directly, but also stateless clients or serverless, as I don't like the name serverless because there are servers there, but it's basically stateless functions running is now all the rage. You want to have your data platform with the ability to support them. And NVIDIA just came with their GPU direct storage. And this is the most effective way of actually feeding these GPU servers with data. And we've shown that on their new DGX A100, you can get around 160 gigabytes a second to every single DGX client, which is over 20 gigabytes a second over 8 200 gig links. And it's even faster than what the RAM on these boxes can handle. So NVIDIA had to come up with their own unique ways of driving tremendous amount of data to their extremely effective engines. And the last access protocol we put here is CSI, which is the Kubernetes storage interface. And we're seeing Kubernetes as really important piece of enabling portability because it actually lets customers run the same application in an extremely similar way, both on their on-premises data centers and in the public cloud and in their edges. So up until Kubernetes came, you couldn't actually run the exact stack on premises and the cloud. And you couldn't run the exact stack between different clouds. And this is how the clouds actually forced customers to stick to one of the clouds, Kubernetes enables tremendous amount of portability. Now, what you can see below, we can extend the namespace to an object storage, but we can also save snapshots to the object storage in a way that any other Weka system can pick it up and keep running. So if the customers are using a centralized object storage or several of these across on-premises, across their public cloud, across the edge, they can leverage Weka running on these different locations and leveraging our snap to object, actually view and access, manipulate, and leverage the same data across all the locations. So this saves a lot of hassle and a lot of work. And just being able to access something as file or as an object or as a GPU direct of the same data saves a lot of duplications. So customers don't have to store their data over and over and over again. And storing is not just expensive because you have to store the same bit twice. It's also expensive because you have to manage what is the most up-to-date version of the data. And now you go into a lot of hassle into making sure data is valid. If you have just one copy of that data, you have your master copy and that's the truth. It makes all of that handling a lot easier. And some very important aspects of portability is the ability to do it in a secure way. We support encryption, we support ACLs, we would let you encrypt with your own key management server, so you can actually burst data to the cloud, leverage the cloud for elasticity, but govern what cloud instances can actually use from your on-prem, let's say HashiCorp Vault or any other KMS. So we let customers port their data in a way that is safe, which is also a really important requirement nowadays, because as I've said earlier, the engine is similar across everyone, but the data is actually the unique aspect. Shani, can you move to the next one? So now we're talking about scalability, and scalability has several facets and they're all important. You need to be able to start small and scale. And the ability to start small at scale is because many of these projects start as an idea, they start as a proof of concept. You don't know how much data you're going to start with. If you're going to pick traditional legacy storage vendor, the first question they're going to ask you, hey, how do you size it? And if you don't size that solution correctly, you're stuck because you either overpaid and you bought something too big, or very quickly you're going to see that you bought something too small and you have to buy again. So when you're picking a solution, it's very important to pick a solution that can actually start very small and then increase in size in a graceful way. So you want to be able to start from a few dozen terabytes and finish up with a solution that has many, many hundreds of petabytes and sometimes even exabytes. And you also need a solution that can handle a lot of files in a single directory. So because if you look, let's say, autonomous driving cars now have 8 cameras, they take 60 frames per second. In just 30 minutes, a single car generates 100,000 files, which is usually the good limitation on how many files you can put in a standardized directory. But what we're seeing with our customers, they're actually storing all the images from the same geo in the same directory by model, because this is what makes sense. So you actually need directories that can store hundreds of billions of files in a graceful way without performance degradations, and be able to do it for, again, starting very small or growing very big. Now, Shani, if you can go forward, going back to Julia's example. if we're looking at a very popular NAS, scale-up NAS solution, if you're unhappy with the performance you got from one system, the only thing you can do is buy a second system and then arbitrate around the two. With Weka, we don't have performance scaling limitations. So when you have with Weka, you can start if you need, let's say, an 80 gig, and you would add the server, it will be 90 and 100 gigabytes per second. Obviously, this is an example. You can buy, because we're software, a single unit that would provide a lot more than that in each edition. And you can choose to add the performance and the scale at a very granular level. So you don't have to pre-buy large chunks just because this is the limitation of that specific box that you ended up picking. Now, as we just talked about, hey, how are we scaling performance? So if we go to the next important point, the next important point is actually performance. And what we're seeing at AI machine learning, the amount of different applications running, the amount of different requirements are mind-boggling. And customers have the different stages. They ingest the data, and then you have one kind of requirement, and then they go label the data, and they run the training, and then they run the inference, beginning with the inference as part of the QA of the training. And if you're an autonomous driving company, you want to infer the new protocol through the endless amount of driven miles, and this is actually the high requirement for data. So customers are looking for solutions that can actually support mixed performance and good mixed performance over the same data. And as Julia mentioned, they're looking for high throughput for some of them, and they need a lot of low latency, a lot of metadata on the others. And they want to know that as they scale, they can actually gonna keep getting the same kind of good performance. So if you go to the next slide, what we're showing here is an example is our spec SFS numbers. And what you can see here, Weka got actually the only company to submit all 5 workloads of the spec SFS benchmark. And what you can see, the next is Weka compared to the next best solution. And you can see that Weka is the best solution, but the next best solution was always a different platform, between an Oracle ZFS to a DDN box to a Neto box. And what you see, Weka, a single Weka, and we ran it on the single same box, was better for video acquisitions, which is mostly writes, or software build, which is mostly metadata, or databases, which is lots of small files, and EDA, which is a lot of large reads, and VDI, which is a mix between reads and writes. And you didn't have to go and configure a different Weka. You can go back to the results here. It's actually the exact same system to get good performance across the different workloads. And up until Weka came, no single vendor was actually the winner of all the 5 spec SFS workloads. Similarly, on the IO500, Weka is the fastest parallel file system on the IO500s for years now, and we were running that on AWS. Who would have thought the public cloud would be the fastest HPC platform? And on Stack, we're showing, hey, Weka was faster for time series databases than local Optane, local 3D Crosspoint, which is insane, direct attached, or in the all-flash NAS, or a SAN solution, NVMe of a Fabric SAN, or obviously all the other NAS solutions. So we're showing, hey, we go on these benchmarks, and a single system that provides shared data platform is actually the fastest and allows you to be most effective with the engines that you're buying. And it also, because no matter what happens at Weka, the latency stays flat, we allow you to go by twice the compute, and you're going to get twice the results. And if the latency starts going up, what you need to do is just increase the Weka, and by magic, latency will go back below. And in this case, we're actually breaking the myth that, hey, you can only scale to so many clients, and at some point adding clients is a diminishing return because you don't get enough fast access to the data. We actually show our customers, hey, if you can afford more clients, add more clients, and you're going to process it faster. And this is especially useful on the cloud, because now you can take something that took a month and finish in hours, and if you just can get enough instances on AWS. Shani, can you go forward? So as I mentioned earlier, we are now a data platform. A data platform requires good support to many of the libraries and a wide range ecosystem. So it doesn't help you, hey, I'm buying some solution to hold all my data to make sure I'm effective, and then not be able to actually leverage it. And the second aspect is support for containers. And the way many of the organizations now are achieving interop between different workloads is actually containerizing them and leveraging Kubernetes. There was some struggle in the years before how to containerize, what to use, but over the last year or so, there's been tremendous amount of consolidation, and it's quite apparent that the industry is standardizing on Kubernetes, mainly because it's such a terrific solution. So if you go forward, you need to be able to leverage data platform that can actually run or your AI application and support all your data analytics, including Hadoop, including SAS Grid, the Elasticsearch, Spark, all the life sciences between Parabricks or Atomwise or Petagen, the cryo-EM ones, and supporting all your container orchestration that has good support for your databases. Actually, this is not something we're promoting very strong, but if you look at the Oracle Hammer benchmark, running Oracle over on Weka is faster than any of the all-flash array block solutions you can buy. So Weka will also run Oracle better than anyone else, and definitely KX is what we used in the Stack benchmark, and we're showing that for the time series databases, Weka is the best solution ever. If we go and thinking about stateful Kubernetes, because Kubernetes was created usually around stateless compute, and it got a lot of initial success, again, in the serverless, which is a word they already said they don't like. But now organizations are taking Kubernetes to a stateful solution, and stateful Kubernetes is hard because what usually happens, and scaling stateful Kubernetes is hard, is because usually what happens when you start small, you're able to run all your containers that need the same data on one host. And then you're just using a local file system, and then you can use direct attached, or you can use some SAN, and it's working very well. But then you are going to add more and more and more hosts, and at some point, you will have to run containers that need to access the same stateful information on two servers, on two hosts. And at that point, everything else goes down and folds back on NFS. And you all know the NFS limitation around metadata, and then applications that used to run extremely fast now start bogging down. And I'm sure all of you have noticed, hey, I take a large tar file, I untar it locally, it finishes very quickly. I untar it in something that has NFS, it can take hours. And this is the same thing you're going to see with scaling Kubernetes. So you, at some point, you're going to be scheduled to run on different servers, and you would be scaled down to the NFS metadata handling, which isn't great. So if you go to the next slide and we look, how does it look at Weka, we're actually enabling the customers to run their persistent storage over Weka. We support Kubernetes natively. We are part of, we're a cloud native provider where you can just get the CSI as part of installing your Kubernetes environment. And then you can access the persistent volumes automatically just by provisioning containers that connect to these persistent volumes when you run. And then we don't force you to have these limitations. And obviously you can still access the same data from stateless on S3, from NFS, from SMB, and you can really enjoy the high portability. The next point is, how do you make sure you can actually leverage the same kind of storage, and please next, over everything you're running? And then being software defined is so important. Now, as Julia mentioned, who supported NVMe first, we actually had NVMe code and NVMe support before you could buy NVMe devices. So we're using some FPGA solutions and software emulators, and we came out with NVMe before customers could actually buy NVMe devices. And this allows you to run the exact same software on your on-premises through the vendor of your liking, and also on the edge and on the cloud. And if you, Shani, if you move to the next point, the next slide, we support the whole ecosystem. So if you like to buy your main data center from one vendor, but you need to run your edges from another vendor because they have a different solution, and you want to run on the AWS cloud, Weka is the only company that actually lets you do it. Also, you can choose, hey, I'm tiering to, let's say, Scalability or Cloudian or Quantum Active Scale or the IBM CleverSafe, but also to AWS S3. So being software driven, being ecosystem driven, we don't tell you what partners to work with. We don't lock you in to a small number of partners. So you can optimize different kind of your business in the way that works best for them. Shanae, if you move next. And the last one is cost optimizing. And cost optimizing storage has two aspects. One, as I said earlier, one of the aspects is, hey, you don't have to pre-size and you don't have to overbuy at the beginning, or if you underbought, you have to throw it away and buy a new solution. You can start small and grow big. And the other part of cost optimizing is making sure your GPUs, very, very expensive resource, is being 100% utilized. And the next one is actually with tiering, allowing to store and manage the active archive in a way that you spend the right amount of money on live data, and when data doesn't need to live anymore, because not all data is accessed all the time, especially when you're storing it in dozens of petabytes and hundreds of petabytes or exabytes, you need to be able to access that data if you need, but you're not accessing exabytes of data every day just because of the speed of accessing the data. So by having a single unified mechanism to manage the tiering, to manage where you put everything, you can actually save a lot. So if we go to the next example, this is an example of an autonomous driving project that was able to cut 20 times, to save 20 times the runtime during their single run to Epoch. And this is because we enabled higher performance. But if we're going to the Genomics England example, the next one, through tiering, they were able to drop down the cost per genome from 52 pounds per genome to 2 pounds per genome. They're currently at 5, but the next step will be 2 pounds per genome. So through smart management of active archive and live data, they were able to save 26 times on a per genome basis and basically grow a lot more genomes and pay not a lot more money. And because they have to manage just a single platform that takes them through their whole data journey, they were able to go down from 10 storage admins to half a storage admin. And now these 9.5 other people actually had time to go and spend on other projects. So we're showing we're not just saving the cost of storing the data and managing the data, we're also saving on how much does it cost to store, to manage the whole thing. So in conclusion, what you get at Weka, Shani, if you can move, we basically enable you to get the limitless data platform because you really have no limits. And we're the only solution that gives you both the simplicity, the speed, and the scale that you need to run AI and machine learning infrastructure. So when you're modernizing, and you probably are hearing a lot of digital transformation and data center modernization, when you're taking your application through this digital transformation, Weka is one of the pillars that you should consider to take you into the future. So I think we got to the questions part.
Yeah, so if there are any questions, we're happy to take them. I want to say a couple of things. First of all, Julia and Liran, thanks for joining us for this session. I hope everybody found this session beneficial. I certainly did. Again, we'll send the recording in a few days. Before we conclude, I want to make you aware of 2 relevant resources related to the topic that we just discussed, AI and machine learning workloads. So first of all, we just released the State of AI and Analytics Infrastructure 2021 report. We essentially surveyed, we spent over 2 months surveying over 500 respondents. And essentially it provides stats around the most common AI initiatives by industry and vertical, what AI strategy are most common by vertical, whether it's in-house, whether it's out of the box, GPU versus CPU adoption, cloud adoption, where you're sourcing the data from and how much data you're sourcing, the R strategy, and much, much more. And so a lot of these things are kind of things we touched upon. We talked about kind of the network infrastructure. So there's a lot of information around what are the common network interfaces as well as bandwidth. So that's the first report. You can access that by going to weka.io/report. The second one are the 10 things to learn, 10 things to know before starting with AI. And an overall discussion both about the infrastructure aspects but also around sourcing the data and validating the data and much, much more. You can also find that on our website. So our next webinar will be with Chris Mello from Docs and Files. It's going to be on March 11th. And so we hope that you'll join us. And again, we'll follow up with a recording in the next couple of days. So with that, we'll conclude. Thanks again, Liran and Julia, and have a great rest of the day.
Thank you.
Thank you.